All right, let's jump right into this explainer. We use AI literally every single day now, right? We ask it questions, have it write code, translate languages, but have you ever actually stopped to think about what's going on at a microscopic, mechanical level the exact moment you hit send? Well, today, we're going to trace the exact journey of your text.
You might assume that when you ask something like, "Why is the sky blue?" the AI is somehow pondering the complete answer in a digital brain before it starts typing. And hey, it's totally natural to think that way, because, well, that's exactly how we communicate. We process a question, form a thought in our minds, and then we speak it out.
But actually, no. It doesn't think like a human at all. The idea that it understands your question the way a person does is, well, it's a beautiful, incredibly convincing illusion. Under the hood, it's relying on a lightning-fast mathematical system, a massive sequence of pure calculations.
So today we're taking a microscopic journey through 6 distinct steps: questions and prompts, tokenization, embedding, the transformer and attention mechanism, predicting tokens, and finally, computing power. Let's shrink down and dive right in.
Station 1. Questions and prompts. We're starting at the absolute beginning, exactly where your typed question enters the AI system. Now, in the AI world, your question is called a prompt. But the machine doesn't just read this entire sentence as one big human-like thought. If you type in, "Please explain the TCP three-way handshake in simple terms," that whole chunk is your prompt. But the AI model? It can't just swallow that chunk of English whole. It absolutely has to break it down first.
And that brings us to Station 2, text slicing or tokenization. This is a foundational process for how AI actually processes text.
Here, the system slices your prompt into fundamental computing units called tokens. These can be whole words, parts of words, or honestly, sometimes even single letters. Think of a tokenizer like a digital meat cleaver. Feed it the phrase, "How does AI answer questions?" and it chops those words, and even the punctuation, into separate tokens. Longer words might get sliced into syllables. And once it's all chopped up, every single token gets assigned a unique number, a token ID. Because at the end of the day, computers only really understand math.
Moving on to Station 3, giving meaning, which is also known as embedding. So we have our tokens converted into ID numbers. But numbers alone don't convey meaning, right?
This is where embedding steps in. It turns these tokens into high-dimensional vectors. Basically, it creates this massive mathematical map. See, just having an ID number for the word cat isn't enough. The AI needs to know what a cat is compared to everything else. Through embedding, cat, dog, and animal end up clustered super tightly together in one corner of this vast, mind-blowing mathematical universe, while words like car or truck group together somewhere completely different. Suddenly, the AI isn't just looking at isolated text, it's navigating a giant, complex web of numerical relationships.
Next up, Station 4, the core brain, specifically the transformer and its attention mechanism. Now those mapped vectors enter the true engine of modern large language models.
The transformer has this brilliant superpower called the attention mechanism. Let's illustrate this with a simple sentence. Xiao Ming gave Xiao Hua the ball because he had to go to class. When we read that, our human brains effortlessly know who he is. But remember, AI has zero common sense. It needs a mathematical way to figure out the context. So who is he? The attention mechanism actually calculates the relationship and importance between he and every single other distant token in that sentence. When the model looks at he, it doesn't look at it in a vacuum. It casts a net out to the rest of the prompt, calculating a mathematical weight, an actual score of how much he relates to Xiao Ming versus how much it relates to Xiao Hua. It's simultaneously analyzing the relationships between every single piece of your prompt. This is exactly what makes the transformer such a massive game changer.
Station 5, predicting the next token. Okay, we finally reached the climax of our journey, the aha moment where the AI actually generates its response.
Instead of writing a full essay all at once, the model just uses everything it's analyzed so far to calculate the statistical probability of the absolute best next single token. Say your prompt ends with TCP is. The model runs these massive probability tables. It might decide, okay, there's a 35% chance the next word should be transmission, a 25% chance it's and so on. Relying on all the syntax and patterns from its training, it picks a winner, just one single token.
Once it picks that most likely word, it tacks it onto the growing text, recalculates the entire context, and guesses the next word. and it loops this over and over at lightning speed. It guesses transmission. The new context is TCP is transmission. From that, it guesses control, then protocol, one token after the other. This is exactly why AI text flows onto your screen word by word. It is literally calculating the answer in real time, one slice at a time.
Finally, Station 6, Computing Power. You might be wondering, hey, if it's just guessing one word at a time, why does it need those massive data centers?
Well, those mathematical relationships inside the transformer require an astronomical amount of simultaneous matrix calculations. And that is exactly the kind of heavy lifting graphics processing units, or GPUs, are built for. To predict just one single token, it has to run calculations across billions, sometimes trillions of parameters. Standard computer processors would completely choke on this. But GPUs, with thousands of parallel cores, can crunch these massive matrices simultaneously. That's why generating AI text takes enormous server clusters and incredible networking power.
So, the big takeaway here? AI is taking your prompt, mapping the semantic relationships, and executing immense mathematical calculations to simply predict the next most logical piece of text. It translates text to numbers, maps them into a universe of meaning, weighs the context, and mathematically guesses what comes next. What feels like genuine human thinking is actually just one of the most sophisticated, high-speed statistical prediction systems we've ever built. And that is exactly how AI answers your questions.
This mathematical illusion of understanding is absolutely fascinating. And honestly, it leaves us with one massive question that we're going to tear apart in our next explainer. What exactly is the transformer architecture? How does the math of self-attention actually work? And why did it become the singular beating heart of the generative AI revolution? We are going to crack open that black box next time. Thanks for learning with me today.